Hey everyone. So today gonna keep it simple. We're essentially just gonna do the worked exam one iteration of the worked example um that I had gotten ChatGPT generated a while ago. I tried doing this earlier today as well, and I made a mistake. I realized that, and I'm just gonna film myself doing it live. So let me just copy down the original matrix really quickly. Scroll up so I don't see the answer. All right. So it's A equals 1, 2, 2, 1, 2, 2, 2, 0, 1, 0, 3, 3, 1, 3, 4. So uh, let's copy down over here. Hide that. It's my previous attempt. Um, so starting from this, we have to pick a vector x on the first iteration that starts from the subdiagonal and goes below, right? So for the first column, that is this vector over here, right? So let's just define that. X equals 1, 2, 2. Okay, right? It's pretty straightforward over there. So the norm of x, or the L2 norm specifically, that's what the subscript of 2 denotes, is the root of 1 squared plus 2 squared plus 2 squared, which equals to root of 9, which equals to 3. Pretty straightforward so far. Now we get alpha. Alpha is equal to sine, or the sine of the first element of the vector, times the magnitude, or the L2 norm of the vector, right? Once again, very simple, right? So the sine of x1 is just positive. I'm just going to say positive 1 times 3, which equals 3. Ignore the red signs. That's just Apple Notes math results bugging out. Okay, so we have alpha. Now we do alpha times E1. Now pause. What is E1? So I'm just gonna erase that really quickly. So essentially, to do the reflections, you have to pick a direction. And you can essentially, based on the number of dimensions, you have uh, that many number of basis vectors. So since we have 3 dimensions here, 3 dimensions, right? We can do 1, 0, 0. That's 1. That we can do 0, 1, 0. That's E2. And E3, 0, 0, right? So we have to pick a direction, and that's where this is. These are basis vectors, and because we have the luxury of picking our own basis vectors instead of finding them in a particular vector space, we've just chosen them to be the unit vectors because it just makes life easier. And the easiest way to progress from this point is to just pick the first basis vector, which is this one, right? Just gonna maximize this. Yeah, boy. Yeah, right? So once again, alpha E1 is very simple. We've gotten the first basis vector. Therefore, alpha E1 equals 3 times 1, 0, 0. Pretty straightforward, which equals 3, 0, 0. Pretty straightforward so far. Yep. Yep. So what is the next step? We do x plus alpha E1. Now, I believe this is vector V, called V, which is x is 122. That's correct, yeah. 122, yes. And alpha E1 is 300. So that equals 422. Pretty straightforward, right? Now, what is the norm of V, right? It's like we're computing the norm again, essentially. So that is the root of 4 squared plus 2 squared plus 2 squared, which equals to 16 plus 4 plus 4. So that's the root of 24. And yeah, okay. So U, which is what you do in the next step, which is what you need for the next step, is essentially V, the vector V, this one over here, normalized. So U is equal to V over the norm of V. Very straightforward. Yeah. So essentially, that means it's 1 over root of 24 times 4, 2. I'm pretty sure we're good so far. So what does that actually equal to? Right? So you need root 24 times 4. Let's figure that out. Just gonna get that solved. 19.59. I'm gonna need a moment, baby. Apple, what's up? Tell me. What do you need? Just tell me. I'll come shortly-ish. I feel like I missed something. Let me see. What did I miss? I'm just gonna. We took the norm. Yeah. X plus alpha E1 422 root 24. So 4. Okay, so they did it the other way around, or V and U, whatever. So then, what did I do wrong? Oh, duh, I'm an idiot. It's actually uh, uh, this is so this. There you go. So that's 4 divided by root of 24 equals so 0.816. Yep. And 2 over root of 24 equals 0.428. So V, is that how I know? Oh, sorry, U. I'm just using U, even though it's the other way around over there. It's the same stuff. Equals V over the norm of V, aka we're just U is just the normalized version of V, which is 0.816, 0.408, and 0.408 again. Whoop-de-doo. Okay. Now the householder reflector. This is the actual construction of the reflector. Is I minus 2 times V in the chat GPT, and I think in common examples other places. I'm just going to use U because that's what I used here. U times the transpose of U, which is the outer product, 2 times the outer product. So let's just do the outer product on its own. U transpose equals 0.816, 0.408, 0.408, times 0.816, 0.408, 0.408 again, right? So you just multiply. So the first row in our matrix is essentially multiplying 0.816, 0.816. That'll be the first row, first element. First row, second element will be 0.816 times 0.408, and again, and again. Okay? So I'm actually just going to remove that line I did. By the way, in case you're wondering what I'm doing with the notes stuff where I'm able to calculate it, it's just like an Apple Notes feature thing. You literally just pull up a calculator, but it's just nice to do it in the flow. So there's essentially only three calculations there. There's 0.816 squared. Let's solve for that. What is that? Solve that. That's 166. Okay. Got 0.816 times 0.408, which equals 4.33. And then we have 0.408 squared, which is, I don't know why the solve didn't happen. Just gonna, you can do that again. 0.408 squared equals, the solve point and solve 0.166, right? So those are the values, right? So let's just fill up our matrix over here. Oops, I'm gonna hope. Okay, my mic mode isn't voice isolation. I'm glad you guys did not do that. That's screw it. I'm just gonna tell you guys I farted really loud. Oh, that's gonna be the name of this episode. I farted really loud. That's fun. Okay, so 0.816 times 0.816 is 0.666, right? And then 0.816 times 0.408 is 0.33. And it's the same again, so 0.33, right? And then for the second row, it's 0.816 times 0.408, so it's 0.333. And then it's 0.408 times 0.408, which is 0.166, and 0.166 again. And then the last row is, I think, a repeat of the second row, right? Right? Right. 0.333, 0.166, 0.166. Okay, so that's UUT, right? Now we multiply all this by 2. So let's just figure those out. 2 times 0.666 equals solve. Okay, 2 times 0.333. And I know there's floating point errors here. I'm just gonna like go with it, and then I can compare and contrast. And obviously, I know there's gonna be precision loss, but that's okay. So, these are the only three numbers we need to know right now, because this is a fairly repetitive matrix right now. So 0.332. Okay. So we just kind of replace those values. So 2 UT, aka 2 times the outer product, is essentially this matrix over here multiplied by 2. 2 times 0.66 is 1.332. 2 times 0.333 is 0.666. Then 0.666 again. Then it's point. Dismiss that error. I'm just going to try and take care of that. 0.33 times 2, so that's 0.666. Then 0.166 times 2, so 0.332. It's technically 0.333, but whatever, I'm just going to stick with this. 332. Just, I know the third row is just a copy of that, so I'm just going to copy that down. 0.666. right? So that's that. And I minus 2u ut is essentially just the identity matrix, right? I'm just gonna draw that out just for the sake of it. This is a 3 by 3 or a 4 by 4? Yeah, it's a 3 by 3. So 1, 1, 1. And then it's just gonna be 0 in the off diagonals, right? Minus this whole mess over here. Just gonna copy it back down for illustration's sake. This started with 1.332, 0.666, 0.666, oops, 0.666, 0.332, 0.332, 0.666, 0.332, 0.332, right? So it's pretty straightforward, right? And just like you just combo this. Honestly, the easiest way to remember this is off diagonals, flip sign, and then the diagonals are subtracted by one, which is essentially what that is. So I'm just gonna draw out that completionist thing. So that's 1 minus 1.332 negative 0.666 negative 0.666 uh negative 0.666 1 minus 0.332 negative 0.332 negative 0.666 uh negative 0.332 and 1 minus 0.332 1 minus 1.332 equals, I think it's negative 0.332. Yeah, that's what I thought. 1 minus 0.332, that should be 0.667, 8, there you go, right? And so we just solve for this. That gives us our final answer, negative 0.332. Um, negative 0.332, negative 0.666, negative 0.666, negative 0.666. Oof, this is irritating. 0.668, negative 0.332, negative 0.666, negative 0.332, and 0.668. Yep. So this is a good point in time to do a checkaroonie. Yep, that's basically what we got, right? Negative 0.333 recurring, which is just 332 is the same. 66, negative 0.66, negative 0.66, 0.66. So it's the diagonals that is easy to compare. Everything else is just flipping the sign, which is accurate. I'm just gonna try and make that so that that's not in the way. Yeah, perfectly fine to me. Embed it into the full matrix and continue on, right? I'll skip this step because it's fairly trivial. It's literally just the identity matrix, and then for the bottom right corner of that identity matrix gets replaced by this. It's all that is. And then to actually get the matrix you're going to use for the next iteration, you just do H multiplied by A multiplied by H. And that's it. You're done. So I think I know I said I would do code today. I'm still super sick. I think I had like a stomach bug or something. Yesterday was okay-ish. Today was pretty bad actually. Um, but yeah, I still wanted to push through and do this because this was an exercise I myself wanted to go through of just like, okay, let me just do this by hand once. Try and get in my head, you know? Yeah. All right. I think that's where we're going to call it for today's lesson or today's video. Anyone watching out there, if you're struggling, if you're having a tough time, have faith. I think that's really important. Uh, Even for the learning process, like having that faith is essential, actually, right? Because it's like you're learning something, it's like, oh, I did this, this could be cool. This is not that great, actually. I kind of suck at this. I really suck at this. Man, man, I'm just not even worth it. And then if you push through sometime, if you push through that, right, you get to the space where it's like, oh, okay, this is all right. This is all right. It's fine, you know? And this is a general pattern that emerges like if you're at work and you're working on a presentation or something like that, or whatever it is. And the thing about having faith is that you can skip that middle step where you're like, I suck, right? You can just move towards the improvement instead of worrying about and allowing your mental space to be clouded with these nonsensical thoughts of I suck or I'm a failure or whatever, you know? And having purpose helps with faith and all of that stuff, right? When you have purpose, it's like you can't fail. It's like whatever this is, I can't fail. Like it's part of my purpose. I need to do it, right? And so it automatically just kind of you just start skipping that step. It's like other people have solved this, I will solve this. It's done, you know. Um, in Hinduism and Buddhism, it's dharma, right? It's like your responsibility, your duty, the cosmic order. We've talked about this, right? It's like I have to do it. You just have to, right? And the funny thing about dharma is like it's both. It's like it's seen as responsibility and duty, but it's also cosmic order, right? In Hindi, it's like I'm gonna say the same words, but to anyone who understands Hindi, I'm gonna say them twice, and the tone makes like the entire difference, right? ये तो हमारा धर्म है, it's my responsibility, or ये तो हमारा धर्म है, this is what I have to do. You know, there's like this. I was watching like an Alex Hormozy video, and I've seen like a bunch of them and stuff. I don't like. I like the guy, you know, and he's got some good points and totally valid to take on. But he has this thing about prioritization. It's like prioritization is one thing, and you have to eliminate everything else, right? But I think there is such a point as realizing that there is actually only one thing to do. It's not about eliminating other things, it's realizing that they just are not the thing to do for you, right? Anyways, enough philosophy. We got this. Let's go closing in, or at least making some headway in the direction of closing in on this eigenvalues and eigenvectors thing, because this thing blew out way bigger than I thought it would. Um, Thank you all so much for your time. Have a great one. Bye bye.